Today we're going to build a professional Python SaaS application that scales. We're going to use Django, LangChain, Docker Compose, Celery, task queues, and Redis to build an application that can handle multiple concurrent users. This application will be an AI-powered job listing scraper, so the user can enter a description of the job that they're interested in. It can be free text, it doesn't have to follow a specific format, and then the AI platform that we build is going to find relevant job listings from different platforms. Although we're only going to build a prototype in this video today, we're going to learn important principles and techniques when it comes to scaling SaaS applications or building them in a way that they can scale. If you like this video, let me know by hitting the like button and subscribing, but now let us get right into it. Alright, so this is going to be quite a comprehensive project today, which means we're not going to build it perfectly from scratch. What I mean by that is we are going to add Docker Compose, Celery, task queues, Redis, and so on later on in the video, but we're going to start with a more minimalistic basic prototype so we can get started, and then we're going to change stuff as we go on. So what do I mean by this? We said for this project today, we're going to prioritize scale, which means we want to have a server that can handle multiple concurrent users without problems. So all these users can be submitting requests, waiting for responses, and the server can handle that concurrently without problems. Now, in order to build a prototype, in order to understand what we're doing here in the first place, sending basic requests, having basic user authentication and all that, we're going to build a prototype that can handle just one user synchronously. So we want to see, okay, what are we actually doing here? We have a server, this is going to be running Django, then we have us, the one user that is using this, then we're going to send requests to LinkedIn and also another platform. And the idea is we want to build this basic functionality before we actually make this into something that can run asynchronously with task queues and everything. And we're going to discuss the challenges, but I want to start with a basic version so I'm not starting right away with Docker Compose, Celery, everything. Everyone's confused because maybe you're not even that fluent in Django yet. I want to keep it simple, and then we're going to transition to a more scalable version of that. So this means we're going to start with a local Django application without any Docker, without any containerization yet. And for that, I'm going to open up my terminal and we're going to set up the development environment. Let me zoom in a little bit so you can see what I'm typing here. In general, as always, you can use whatever package manager you want. You can just install everything with pip. You can install everything in a virtual environment. For this video in particular today, though, I recommend that you stick with UV with the same setup that I have, because if you don't do that, you're going to have to use different commands. So if you're not really comfortable with Docker, and you don't know how to set up the Docker Compose files and the Docker files, maybe you will be confused by having to use different commands, because I'm going to always use UV run and you have to use something else. So if you want to just do exactly what I do, I recommend you use UV, the Rust-based Python package manager. You can also install it, I think, by saying pip3 install UV. Otherwise, you can also install it by using Cargo, and on Arch Linux, you can install it by using the pacman package. I think it's called something like python-uv. So once you have UV installed, you can just say UV init to create a project in your working directory, and then you can say UV add in order to install the packages. Again, if you're not using UV, you just say pip or pip3 install in the same package names. Nothing changes, but with UV, it's a little bit faster and you have different commands. So UV add, same package names. And of course, we're going to need Django. We're going to need LangChain, as I mentioned, because we're going to interact with large language models. We're going to need requests, which I think is going to be automatically installed with the other two anyways. Then we're also going to need Celery later on. We're not going to install Celery yet. Same with Docker. We're not going to go through Docker yet. Redis, exact same thing. But besides that, we're also going to use Pydantic to fill a structured output model. So these are the packages: Django, LangChain, requests, Pydantic. So just say UV add or pip3 install these packages. And that's basically it. Now we're going to set up our Django project, and for this we're going to use the Django admin command line tool. Before that though, I'm going to create a directory with the project name, just because I like to have a different name for the core module, for the main module so to say, and for the project name. So I'm going to say here make directory, and I'm going to call this job-SaaS, for example, and then I'm going to use the Django admin command line utility to create a project in this directory. So in my case, since I'm using UV, I'm going to say UV run Django-admin start project. Now the name of the main module, in my case, I'm going to call this core, and then the directory that I want to create this project in, job-SaaS. So this creates a Django project. Let me zoom out to show you what this looks like. I am going to assume to some degree that you're familiar with Django already, or at least that you can learn on the fly, because I'm not going to explain the Django project structure in too much detail or the basics of working with Django. I'm going to assume you know what views are, what the settings are and how they work and so on. But basically we have here this Django application with a core module, and now we can also create additional apps in this project for different use cases and functionalities. And in our case, we're going to have one app for authentication, so login and sign up, and one app for the actual functionality, so interacting with a large language model, doing the structured output, queuing everything, and so on. So we're going to have one app called accounts and one app called jobs. So how do we create these? We go back into our terminal, then we navigate into our project directory, and here we're going to say uv run Django admin again, but this time start app, not start project, and I'm going to call the first one accounts and the second one jobs. We're going to start with the authentication system, and Django makes this super easy for us because we have a lot of batteries included. We already have a user model. We already have a bunch of forms that we can use. We even have views that we can use without implementing them. So setting up, sign up, and login is extremely simple in Django. We just have to go to our accounts app. We have to go to views. And here now we're going to implement a sign up view because that is not provided by default. However, what is provided by default is a user creation form. So that is super simple. We just say from Django.contrib.auth.forms import user creation form. So that is a form that already has the fields defined that we need to create a user. We don't need to define the model ourselves. We don't need to define what fields there are and what validations there are. This is the default provided by Django. And then also from Django contrib.auth, we're going to import the login function. Why do we need the login function? Because we want to log in the user after a successful signup. So what we're going to do here is we're going to define a view called signup, and this view is going to take in a request like every other view as well. And what we're going to do is we're going to accept a post request. We're going to fill the form. We're going to validate the form, and then we're going to create a new user if everything is valid. So I'm going to say here, if request.method is equal to post. Let me maybe zoom in a little bit so you can read this better. If request method is post, then we're going to create such a user creation form. We're going to fill it with the data from the post request. So request.post. We're going to save this as form, and we're going to validate it. If the form is valid, then we're going to create the user and lock in the user. So the user model, as I already said, is part of Django. And with forms, it's even easier because in this case, we just need to say form.save, and that is going to be our user. So the user object is going to be the result of form.save. We don't even need to import the Django user model here manually. And then we just need to log in the user. How do we log in? We provide the request and we provide the user. And finally, we're going to redirect. I think this one needs to be imported. So we're going to say here redirect. We're just going to say return a redirect to the default route. Otherwise, if this is not a post request, of course, we also need to provide the empty form so the user can fill something. So in this case, we're going to say here else just provide a user creation form that is empty. Form is equal to user creation form. And here we're going to render now an HTML file that we need to create. So return render request. And then the file is going to be located in accounts/signup.html. And of course, don't forget to pass the context, which is the form. So form. And also it makes sense actually to unindent this because yes, we're redirecting here if we are successful, but if there is a problem, we're not returning anything. So we should just render this every time. And in this case, we can also render it with the form data. So that is a simple view for signup. And that's almost everything that we need to do here in the accounts app. The only thing left to do is to create a file called urls.py. And here we can link to our views. So on the one hand, our signup view, and on the other hand, of course, the built-in login and logout views. So for this, we're going to say here from Django.urls import path. And then also from Django contrib auth import views as auth views. So this is where we find the login view and the logout view. So what I'm going to say here now is I'm going to say URL patterns. This is a reserved keyword, or not a reserved keyword, but this has to be named like this. So you need to name this URL patterns. It's not just any list. And here now we're going to provide the paths. One path is going to be login, and login is going to lead us to the view from auth views. So auth views.loginView as view. And then we're going to name this just login. Same thing can be done for logout view. So we can just say logout, auth views, logout view as view, logout. And for our custom view here, which is signup, we're going to say signup is, and then we need to import this view by saying from .views import signup. We're going to say here sign up, name, sign up. Now, what we can also do here is we can provide a custom template or a custom HTML file here for the login view by saying in asView template name is equal to accounts/login.html. So this makes sense if you want to customize the way this looks, because the view is going to be the default view, but you can use a different template with the form and everything and customize it with your own HTML code basically. So now let us create the HTML files. We're going to go here, right click, create a new folder, templates, and in templates, we're going to create another folder, which is again named accounts. This is just how it works with Django. And here now I'm going to say login.html. And basically all I want to do here is the basic template for HTML5. I'm going to call this now login. We're not going to add a style sheet yet. Later on we will, but we're going to copy paste this then. So to not have any time wasted on just design stuff. Then I'm going to say here form method is equal to post. The action is going to be equal to, or actually we don't even need that because we're going to just post on the same endpoint. So we can just say method post and not provide an action. And essentially we just need to render here now the form, which is the form that we get as paragraph, so as P. And of course, in order to be able to do that, don't forget to include the CSRF token. Besides that, of course, a button of type submit to actually log in. And I think it also makes sense to add an anchor tag, so a link here to the sign up page, which is going to be here now. Here we can use it, URL for sign up. And we could say register here or something. And maybe to have this in a new line, let's make this a paragraph. I'm not sure if this is necessary, but we're just going to do it. Then maybe one last design thing. Let's add a heading here to know that we're on the login page. And that's essentially it. This is our login HTML. We can basically copy this now, create another file called signup HTML. And here now we can paste this and we can change this to sign up. And the only difference here is going to be that we change this also to sign up and that we then redirect, or not redirect, but that we have a link to login where we can say login here if you have an account already. Of course, what also needs to be done for this to work is we need to go to core, we need to go to URLs, we need to include these URLs. So we need to actually say import also includes. Then we're going to say path is going to be auth. Let's say it's going to be auth/ and it's going to be not admin, sorry, what am I doing? Include accounts URLs. And of course, we need to add this as an application to Django. So installed apps, we're going to add here accounts and also jobs. Now, maybe you're wondering why I'm using accounts for the app and auth for the path. It's just because I prefer to use auth, but auth is already reserved in Django for the built-in auth system. So I'm just using, in this case, accounts as the name, but I still want to use auth as the URL just because I like this. So actually, we should be able to use this now and see if it works. We should be able to say UV run Django, or actually, we're not going to use Django. We're going to use manage py run server. This runs the server locally. The model doesn't need to be migrated to the database because we already have this as part of the default Django application. And now here, of course, this doesn't work. But if I go to not API auth/login, if I type something, I should not be able to log in. What does it say here? No such table auth user. Okay, so of course we need to do a migration because no matter what you do, you always need to do a migration. We just don't need to make the migration. So I still need to do migrate, and then I can run the server again. Let's go back and just log in as somebody here. Please enter a correct password and username. Now I can go to register. I can sign up as admin with a password admin123 admin, admin123 admin. Yeah, that of course I get 404 because we don't have a default route. But if I now go to /auth/login and I type something else again, it doesn't work. But if I type admin123 admin, then I should be able to log in, and I still get the not found because it redirects me to accounts profile, which doesn't exist because that's what the login view does. But essentially you can see the login works. We just don't have anything to go to from there. So let us change this by starting to work on our jobs app. And we're not going to focus too much on the Django stuff yet. I'm going to create here a file called services.py. because we're going to talk about the functionality first and how to integrate it into Django. Remember, our goal is we want to have a user. This user provides a prompt like, I am looking for a job as an ML engineer in Paris, for example, with some other conditions maybe. And what happens then is we have some agent or some model that takes this, calls some tools, so tools being called, and these tools then do something, we get some data, and this data is then transformed into a structured response where the user gets job listings with some key information and also some links. So key info, link, etc. We get job listings, essentially. I know you're not seeing the whole thing now, but you get the idea. So later on, we're going to do this asynchronously with queues, but now we're going to just have some model that calls tools and gives us a response. Now, since we want to do this at scale, or at least we want to be able to scale this easily, we need to make sure that 1,000 users or 10,000 users or 100,000 users can actually send these requests simultaneously without breaking our system, without us being blocked and everything. And for this now, we're going to use a provider that allows us to easily do that. For this, we're going to use BrightData today. This is a platform that makes it easy for us to access these data sources and also to do that at scale. Of course, you can also do it just like this in Python with 1 or 2 users, but the moment you start scaling this, the moment you start getting more and more clients, more and more users on your application, it's going to break. You're not going to be able to send all these requests from your server. You need to have an ecosystem, a platform that allows you to do that easily, which is what we're going to use BrightData for. They're also sponsoring this video today. I need to mention that for the sake of transparency, but this is a necessity in this kind of project. If you want to access these data sources, you're not going to be able to do it from your own server without any platform like BrightData. So you can create a free account here, then you can go to your user dashboard. Once you're logged in, you can then go to web scrapers, then you can go to web scrapers library, and here you will find a bunch of different tools for scraping different sources. In our case, the interesting one is going to be LinkedIn and also Glassdoor.com. And for both of them, you will find a scraper called Discover by Keyword. Also for LinkedIn here, you will find one called Discover by Keyword. There it is. And these two are what we're going to use to get the information about job listings, because these are real-time data sources. This is not data from yesterday or from 2 days ago or from a week ago. This is data that is real-time. This is the data that exists right now. So in order to be able to access these sources, all we need to do is we need to get an API key. So in BrightData, you can go to account settings, you can go to user management, and then you can go here to API key. So either you already have one or you just create a new user and a new API key. In my case here, I just have to go and refresh the key that I already have. So I'm going to get a new one, and then I have to copy it and paste it into a file that we're going to discuss here in a second. So in my case now, I viewed the key, I copied it, and what I'm going to do next is I'm going to go back into my project. I'm going to create a new file here at the top level of the project. So I'm going to close all of this, and I'm going to click on Job SaaS, right click, new file, and I'm going to create a file called .env, so for environment variables. And here now I'm going to say BrightData underscore API underscore key is equal to, and here you want to paste your key. So whatever your key is, just paste it here. And you want to do the same thing for OpenAI, because you need to have some model that you interact with. Of course, feel free to choose a different provider if you want to. In my case, I'm going to say OpenAI underscore API underscore key is equal to whatever the API key is for OpenAI. I'm going to put the right keys into this file, and then I'm going to close the file, of course, not show it on screen. And I'm going to be able to use these two keys in my application. Now, in case you don't know how to get an OpenAI API key, you just have to go to platform.openai.com. Then you have to go to settings. Then you have to go down here to API keys, and then you can create an API key or use an existing one. So once we have all of this, we actually need to install an additional Python package so that we can actually load the environment variables into our application. So I'm going to say here uv add python-.env. And now we need to load the .env file on a project level. So I'm going to go to core settings. I'm going to go to the very top, and I'm going to say here from .env import load.env, and I'm going to say load.env. This is going to load the environment variables, so the keys basically into the environment of the application so we can actually use them. For this, we're going to use the OS package. With os.getEnv, you can get a key. So if I say OpenAI API key, this is going to give me the key like this. So now for test purposes, before we start doing anything in Django, let us open up a test PY file, or maybe we can use the main PY here created by UV and play around with BrightData to see what kind of data they expect from us and what kind of data we get from them. So for this here in this main PY file, I'm also going to say import .env, or actually from .env import load.env, and I'm going to load the .env file, which is in job SaaS.env. And then we can also just use the API keys here for test purposes. I can run this file without running the Django application, so it's not all interconnected. And now let's take a look at BrightData and see what kind of interface or what kind of data they expect from us. Let's go to the LinkedIn one. So I'm going to go back to web scrapers library, linkedin.com, discover by keyword. Then I say I want to use the scraper API next. And here now the interesting part is the API request builder. So here we can basically see how all of this works. Now maybe let me collapse this. This is the curl request. I prefer looking at the Python request. Theoretically, you can just copy paste this here from BrightData, and not just theoretically, actually you can do that. You can also provide parameters here if you want to, but you can see how it basically works. We have a URL, which is the basic BrightData URL or API URL that we use. Then we have authorization, which is where we put our API token. We have content type JSON, and then we have the parameters. What dataset do we want to use? The dataset ID means the scraper we use. This dataset here is the LinkedIn keyword scraper. Another dataset ID could be the Glassdoor keyword scraper, for example. And then we have other parameters that we can also specify. And then we have the data, which is our filters or our keywords. So let us just go ahead and copy all of this. Let us go back into Python. Let's just paste this here. Of course, we also import requests. And we can take a look at how this works now. So we have the URL, the headers, fine. We have the parameters. I'm going to add one here in a second. The interesting part that the agent or the LLM is going to control is the data section. So in this case, we don't need both of these entries. We just need a single one. We can filter for location. We can provide a keyword. We can provide a country, also a time range, a job type, an experience level. We have a bunch of things that we can specify here. And right now, of course, we have the default values from BrightData. We have Paris, product manager, and all that. But later on, we're going to just let the model define it. So the user is going to provide a prompt, an unstructured prompt. The model is going to define how to fill these fields. But the interesting thing is, what does the data look like? So all we have to do is set all of this up, then post to this endpoint, and then we're going to get a response. Now, since I don't want to use too much data here in my requests because I want to save some credits, I'm going to limit the results. You don't have to do this. I mean, to some degree, probably you should do this, but you don't have to do this to such an extent that I'm going to do it here. I'm going to limit to 5 results. You can limit to 30 if you want to, but keep in mind that the results that you get, if you just feed them into the LLM, you're going to use a lot of tokens. So there is a context limit. There is also a money limit to some degree. So find a limit that works for you, but I'm going to set one up. So I'm going to say limit per input is going to be 5. In an actual application, probably you want to turn this up. But now for demonstration purposes here, 5. So let's run this and see what happens. In my case here, I get a problem. So of course, one thing that's missing is we need to enter the API token. So I'm going to go and replace API token by OS getEnv. And then I'm going to provide here the BrightData API key. Of course, we need to import OS as well for this. And then just run this and see what happens. We get a snapshot ID, so we don't get any data. This is important because this snapshot ID now is also asynchronous. So we submit a request, we don't get the response immediately, we don't get all the data immediately. We have a job, the job is going to run, and once it's finished, we can get the result from the snapshot ID. So in our workflow later on, we're going to do this automatically. Now, for the sake of this demonstration, I'm just going to comment not all of this out. I'm going to comment this part out, and we're going to say this was already done. So what I'm going to do next is I'm going to take the snapshot ID, and I'm going to try to get the data from it or for it. So this is the snapshot ID. How do we now retrieve the results? So on the one hand, on BrightData, we have an endpoint for checking the progress. So there is a URL that looks like this, https API brightdata.com/datasets version 3 progress. And then here we put the snapshot ID. So that would be the URL to target with the snapshot ID. And this is going to return the status of this particular job. Now, it makes sense, of course, to use the same headers as before, but then basically we can just say print requests.get URL headers is equal to headers. Then we're going to just assume that this works. We're going to say JSON, and from the JSON object, we're going to get the field called status. Of course, we can also get an exception, but if everything works fine, we're going to get, in this case now, ready. So this was already processed. We waited a couple of minutes already. So now this is processed and we can actually get this. Otherwise, we can get something like, I'm not sure what the word is, maybe pending or processing or something like this. But if it's not ready, it's not ready. So you cannot actually get it. However, when it is ready, there's actually also another URL, which looks like this: API BrightData.com datasets version 3 snapshot ID, and then format JSON. This basically gets the result. So if I say that is the URL, now we can comment this out. We can actually get the result data. We can actually get the data that we requested by sending a GET request to this URL. So very simple. We can say response is equal to request.get URL, headers is equal to headers. Then we can raise for status in case anything goes wrong. But if this works, we can say response.json and just take a look at the object. So we're going to run this now. This is probably not the best way to look at this, but we can see there's a bunch of data. And that is, yeah, basically it. This is a lot of HTML data. There's also a lot of other data. You can see here location, keyword. This is basically the query. We can see the URL, we can see the company name, the job location, everything. So we do actually have a JSON object. We also have some HTML code, which is basically, I think the field is called, let me see. There you go, job description formatted. This is basically the field that contains all the HTML. And that is it. This is what our LLM is going to get. This is what it has to work with to give us then a minimal structured output. Now, of course, the same thing has to be done for the Glassdoor scraper. So we need to go also to this Glassdoor job listings by keyword search. Here we have different parameters, not entirely different, but to some degree they're different. They're not exactly the same. So it makes sense to also go here to Python and to copy this code and adjust it according to your needs. But we're not going to do this in the test script anymore. We're now going to actually do this as a service function in our Django application. And we're actually also going to already define these as tools, as LangChain tools for our LLM or model. So let me go back to main PY. Let's just go with what we already had. This is the first part. You want to do the search. You want to get the snapshot. You want to create the snapshot. And then the second part is getting the result of the snapshot. So what we're going to do here is I'm going to copy all of this. I'm going to go to services. I'm going to create here a function, search jobs on LinkedIn. For now, let's just paste the entire thing. Of course, pay attention to the indentation. The URL is going to be the correct one here. The headers are also correct. We, of course, need to do a bunch of imports here. So we need to say import OS. We also need to import LangChain stuff, but for now, we're just going to write the functions. We want to have these parameters here, which are going to be fixed. This is going to just change for Glassdoor later on. And the data should be something that the model can fill, which means that we need to have some parameters up here in this function that are then put down here in the data dictionary. Now, since this is going to be used by a model, we need to also provide type hints. It makes sense because the model needs to know what kind of parameter is expected here. So we're going to start here with location, which is a string, keyword, which is a string, country, which is a string, experience level, which is a string, job type, which is a string, company, which is also a string, remote, which is also a string, location radius, which is also a string, and time range, which is also a string, but it's going to be the default past month. So maybe to have this displayed in a more appropriate way, let's go and do it like this. This means more lines of code, but we can at least see all these arguments. And now we can just take them and put them down here into the dictionary, which should also be restructured like this. So basically we can just swap here location, keyword, and the rest of the fields as well. Then, of course, we get the response, which is going to just be a snapshot ID. And here we need to automatically manage this. So we need to actually say snapshot ID is equal to, and then we need to get the response. Actually, we should raise before that. So if there is a problem, we should raise for status. Also, we should import requests. And after we have raised or not, or actually when we have not raised, we want to get the snapshot ID, which is going to be response JSON snapshot ID. Now, since we're going to do this synchronously for now, just to see how it works, then we're going to make it more professional and scalable. We're just going to wait endlessly, or until the snapshot is ready before we retrieve it in the same function. So we're basically going to block the LLM. We're going to say wait until you get the actual result. So for this, let's go back to our main.py. How did we check if a snapshot is ready or not? We used this. So I'm going to copy that. I'm going to paste it here to services.py, basically just a different URL now for checking and a different request being sent. And what we can essentially do is we can say while this here is not equal to ready. This means that we're not ready, so we can just wait. We can do some time sleep 5 or something like this. Of course, this needs to be imported as well. But basically just wait until the job is ready. And once it's ready, we can go and say get the actual data. So back to main.py again. The last request here is actually getting the data. Copy what we wrote, put it here. Response is getting the data for this specific snapshot. Raise if there's a problem, otherwise don't print, but return to the agent. That is how you can do that on LinkedIn. This is the code. It's quite simple, and the code for Glassdoor is going to look exactly the same, just with a different dataset ID and a couple of different parameters. So let's just go ahead and copy this function. Let's go to the bottom. Let's paste it here. Let's change LinkedIn to be Glassdoor. Zoom in a little bit. And here now we just have to drop experience level, job type, company, remote, location radius, and I think time range 2. Yeah, time range 2. But we keep location, keyword, country, and then we of course need to swap the dataset ID. How do we know to which one? We go back here. We are already at Glassdoor, and we just have to take this one, this dataset ID that is here in the API request builder. We swap it here to be the other one. This is now the Glassdoor dataset ID. We still limit to 5, and we just drop these keywords. There you go. We implemented the same function for Glassdoor. So now we need to take these two functions and turn them into LangChain tools so they can be used by an agent. Now we're going to use an agent and not a standalone model here because we want to be able to use these functions in combination. Maybe I want to look for jobs on LinkedIn and then also on Glassdoor, and then I want to summarize the findings from both platforms. So in order to be able to do that, we're not just going to initialize a chat model, we're going to actually use an agent. So we start up here by importing from LangChain.agents, the create agent function, and from LangChain.tools, the decorator tool. This tool decorator can be put on top of a function to make this function a tool. We can provide a name, for example, search jobs LinkedIn, and then we can provide a description, which is probably the most important part here, because we need to communicate to the model, to the agent, what this function can do. So here I chose the following description. Of course, you can adjust this however you want, but I said search LinkedIn for job listings using parameters. Then I provided all the parameters that we can specify. And in the end, I said based on user input, this function returns all found job listings. So later on, we're going to change this, but now we have literally this one function that sends the request and gets the information. Later on, we're going to, as I already mentioned a couple of times, do it asynchronously. So we're going to send a request. We're going to get a snapshot ID. This needs to be stored somewhere. Then it has to be retrieved again. So it's going to get more complex. But for now, this is what the tool does. It sends something, it receives something, and that's basically it. So I can copy this annotation here. I can go down to the next function and I can just paste it here. I can change LinkedIn to Glassdoor, then also here in the string, Glassdoor. And I should also remove most of these parameters. So basically all of these here based on user input, but the rest stays the same. So that's essentially it. Now we can go to the bottom and create a final function for this synchronous approach here, which is going to be calling the agent, invoking the agent. We're going to say here, search jobs with agent, and I'm going to take a prompt as input, which is a string, and this is also going to return a string. Not that this is particularly important here. And now we're going to just initialize a LangChain agent. So I'm going to say here, create agent. We're going to choose a model. I'm going to go with one of the models that can use tools, but is actually quite cheap. So GPT 4.1 mini. Of course, if you choose a more capable model, you're going to get better tool use, better summarization and everything. But the important thing is that we want to pass here tools. So tools is going to be just the list of functions that this agent can use. We're going to pass here the search on LinkedIn and the search on Glassdoor tools. And to now invoke the agent, all we have to do is we have to say agent invoke, and we have to pass a message history. This message history contains dictionaries. The first one is going to be a system prompt. Now we could theoretically also use the message objects from LangChain, but for now I'm just going to do it like this. Later on we can change that. The content of the system message will be the following. You are a helpful assistant for finding job listings via LinkedIn and Glassdoor based on user prompts. Then basically we just say role user, content is going to be the prompt. And of course, that's not exactly correct because what we're missing here, actually this takes a dictionary, and the dictionary has to point to, or has to have a key messages that points to this message history. So we have to do it like this, and then we need to indent this and to indent this. And of course, don't forget the comma because otherwise you're going to get syntax errors. So there you go. That is how it works. And to get the final result from the agent, we need to say return, and then actually I need to store this as a response object. Response is going to be equal to response messages, get the last message, and then get the content from this last message. And I'm not sure if we can do this with an attribute, so I think we need to provide square bracket messages like this. So response messages, last message, the content of the last message is going to be the text that the agent produces in the end. So next we can actually build a view around this. We can go here to views. We can create a function search job view or something like this. Takes in request again. Let's keep the conventions here. And we're now just going to say if the request method is equal to post, then we're going to process this. So we're going to assume that there is a field called prompt, and this prompt is going to then be just fed to the service function, which we of course need to import. So let's say here from services, we want to import the search with agent function. That is what we're going to call when the user submits a prompt. So we're just going to assume here that we have a prompt in the post object. So we're going to get this prompt with the get function. This is a dictionary, so that is going to be our prompt. This prompt has to be fed to search jobs with agent. We will have to wait a while because this is, as we mentioned a couple of times already, synchronous. Then we're going to get a response here, or let's call this result. And this result is what we want to show to the user, so we need to return a page where we see this result. So for the sake of simplicity, let's say we just render some file called results. Of course, we need to say first jobs results.html. And then we pass as a dictionary here, of course, result. So that's quite simple. Otherwise, what we need to do, we need to serve some HTML file, render, request, and this HTML file is going to be for the search. So let's say search.html. So let's go and create these two. Again, we go to jobs, we create a new folder, templates, we create in templates a new folder called jobs, and then in jobs, we create these two HTML documents. So results.html is going to be quite simple. We're not going to do anything fancy here. Let me still use the HTML5 template though. So I'm going to say here results, result has to be rendered. So this is just going to be the raw text from the large language model, which doesn't have to be very well formatted. So we're just going to see the result here. And the other page is going to be search.html. Same idea here, just a basic template. Then the title is going to be search. And then here we're going to have a form. This form is going to have an action post. It's going to be posting onto itself actually, so we don't need to provide any URL here. And then we're going to say we just want one input field of type text. And this input field type text will have the name prompt because that is what we're asking for in the backend. And essentially that's it. Then we can say here button type submit, and we can say that this is search. And of course, don't forget the token. There you go. And of course, we now also need to have URL patterns here. So new file urls.py. This is going to be again from Django.urls import path. Then URL patterns is going to be a list, and it's going to be path. And here we're just going to have search. Search is going to be the search view. So for that, we need to say from views import search job view. Search job view is going to be called search. So the name is going to be search. And that's the only view we have, even though we have two HTML files. We have one results and one search file. So it's still one view, one endpoint, so to say. And now in URLs, not in this one, but in core URLs, we need to also include the job URLs. So let's just use the default route here, and let's say it's jobs.urls. And don't forget the comma. Cool. So let's go and try to actually run the server. So we're going to go into job SaaS. And we're going to say uv run manage pi run server. And we can open this in the browser. There you go. We still have nothing, of course. But if I go to search, then I can provide a search here. Let's go and say ML engineer in Lyon from LinkedIn. I know this is not the most beautiful design, and probably we're going to get some error here. Let's see. We get page not found. Perfect. Of course, I get this because the action is post. It shouldn't be post. The method should be post, obviously. So yeah, this was a very stupid mistake. Let's reload. And now we get another problem. Yeah, of course. So LangChain, for those of you who don't know how it works, basically you don't just include LangChain, you don't just install LangChain, you have to install LangChain and the provider that you want to use. So basically in a terminal, you need to say, let me clear this, you need to say uv add and then LangChain. And in square brackets, you need to provide OpenAI, Anthropic, Mistral AI, whatever you want to use. So I have to surround this here with quotation marks, and in my case, OpenAI to be able to use that. Otherwise, it cannot access OpenAI models. So this is important. Let's see if we have any other mistakes here. Let's resubmit. Now it's loading, so it seems to be working. Let's see what's happening in the command line. Nothing for now. This will take some time because it now needs to load the data from BrightData. BrightData is going to have to run the jobs. You can also, by the way, see on the various endpoints. Now I need to LinkedIn one. On the different endpoints, you can see here logs, and you can see the jobs that you have submitted. Now in this case, all of them are ready, so it shouldn't take too long. But now we get there was an error due to the country code validation. Okay, so maybe we can help our agent by providing a better description. Let's go and say, when providing the country code, always use the code. I mean, that's kind of redundant, but let's say EG, it would be DE, it would be FR, it would be IT, it would be AT, and so on for the various countries. Let's see if this helps. If not, we're going to have to do something else. Let's go back now to search. Let's try the same thing, search. And now you can see here in BrightData in the logs for the LinkedIn endpoint, I have running. So this is the snapshot ID. It was sent and now it's working. Once this is done, the model will check if it's done. It will see it's done right now, for example. And at some point I will get the response. Now, of course, when I get the response from BrightData, I need to get it and send it to OpenAI to get the response from GPT 4.1 mini. In this case here, I got it. Here are some ML engineer job listings in Lyon from LinkedIn. There you go, with a link and also with locations and so on. Of course, formatting is garbage. We don't want to use a tool like this, but you can see the raw functionality is here already. Okay, so all of this was a very basic proof of concept. Now we're going to start making this more professional. Since we want this to be able to scale, we need to do this asynchronously. I mentioned this 5 or 6 times already in this video. And because of that, we need to also store information, because if I get a snapshot ID and I don't deal with it right away, I need to somehow store it somewhere and be able to retrieve the data later on when it's ready. So what we're going to do is we're going to go to the models py file and create some database tables, database models, same thing essentially, where we're going to deal with the LLM results. So I'm going to have 3 classes here. One class is going to be the LLM result. All of them are going to extend the model class from Django. Then for a result, I'm going to have multiple job listings. So the result is going to be the whole thing, and the job listing is going to be one specific job that is listed. So here I'm going to say class job listing result, which is going to be models model again. And finally, we're going to have a snapshot, because before we have a result, we also need to have snapshots, and we have multiple snapshots per result. So maybe I have Glassdoor and LinkedIn. Maybe you want to also attach a different source, and then you want to be able to retrieve all of them. And only when all of them are ready, only then do you want to actually process the summarization of the result. So class snapshot, models model, pass. Cool. So for our result in general, I want to have some status choices. So I want to be able to say that our result can have 3 different states. These 3 different states are going to be tuples. They're going to be called pending. So we're not even starting yet. This is queued, but nothing is happening. Then we have processing, which means that we're just waiting for it to finish, but it's already working. And then we have ready, which is basically it's done. And then for the result itself, I don't want to store too much because the listings are going to be stored in this class. The snapshot is going to be stored here. Here we just want to store some basic information for listing the different results. So I want to have a title, which is going to be models, char field. Let's go with a max length of, I don't know, 256 or something. Then let's go with the prompt that the user submitted. So that's also going to be a char field. Let's actually do it like this, prompt. Maybe we shouldn't cap this, or maybe actually let's make this a text field, not a char field, so we don't have any limitations here. Then the status is also going to be a char field. So that is going to be with a max length of, I think 64 is enough. And then we can say choices is going to be equal to status choices. The default should always be pending. And then each of these results should only belong to a specific user. I don't want every user to be able to see all the results. So I want to have an owner of this result, and this owner is going to be a foreign key to the user model that is part of Django. So here we actually need to import the user model from Django by saying Django or from Django contrib auth.models. We want to import user. Then this is going to be a foreign key user on delete. When a user is deleted, I also want all the results to be deleted. So cascade and related name is going to be results, or maybe let's call this LM results. Nice. So now for the job listings, I'm going to copy and paste most fields because it's all just character fields and there's no reason that I should type them out manually now in this video. Basically, we have title, job URL, job type, level, summary, salary, posted. And applicants, what do these mean? Title is just the name of the job, I guess. Job URL is going to be the link to the job. Job type is it full-time? Is it part-time? Is it an internship? Level is going to be entry level, senior level. Summary is just going to be a text summary, a concise text summary of what this job is about. Salary, obviously, the amount of money you get. Posted will be the time, when was this posted, and applicants, if available, on LinkedIn is oftentimes available, how many people have already applied to this position. Now, another field that we need, since this has to be connected to an LLM result, we need to now have another foreign key, which is the LLM result of this job listing. So it's going to be models, foreign key, LLM result. Also here with cascade again. And the related name is going to be job listing results. Now, of course, my camera is blocking this, so let me scroll down. So that's basically it. This is one specific job listing that belongs to an LLM result with multiple job listings. We also have snapshot, which is also going to have this one-to-many relationship to the LLM result. The idea is that I can have multiple snapshots waiting, then all of them are ready, and I only want to summarize the result when all the snapshots are ready. And I also want to know which listings belong to which query. So this is why we model it like this. Then for the snapshots, we're going to do the following. We're going to have the snapshot ID, the most important part of the whole thing. So that's going to be a character field. Let's go with max length 256. And then we're also going to have a Boolean, ready or not. So that's going to be a Boolean field. Then we're also going to keep track of the raw data that we get from the snapshot. So we're going to say data is equal to models.json field. So we have just the entire thing we get from the snapshot. And then, of course, we also need to link it to the LLM result. So we do the same thing as above. LLM result equal to models, foreign key, LLM result on delete, models cascade, related name is going to be snapshots. So that is basically our database model. Quite simple. The LLM result belongs to a specific user. We have multiple results per user. Each LLM result consists of multiple job listing results, and each LLM result is also attached to a couple of snapshots that all need to be ready and loadable before we can actually summarize the entire query or the response to the entire query. Now we need to go ahead and adjust the logic of our LangChain tools because we no longer want to be waiting for the answer. We want to process this asynchronously. We want to just get the snapshot ID, store it in a database, and then retrieve it once it's ready. For this, of course, BrightData already does this in an asynchronous way. We submit something. They are creating the snapshot. We have the ID, but we don't get the result immediately. We also don't have to wait for the result. BrightData already queues this up and gives us everything once it's ready. But for our own summarization, for our own workflow, we still need to have this asynchronous approach, especially for the summarization, but also, of course, for loading the snapshots once they're ready. So what we need to do now is we need to get rid of all of this because we're no longer waiting for the result to be ready here. We're no longer retrieving the actual final result. What we want here is we just want to get the snapshot ID and we want to store it in a database so it can be used later on in a different function at a different place in our code. So the problem here though is when we look at the models file, you will see that the snapshot belongs to an LLM result. This is a non-nullable field, so we need to have an LLM result in order to be able to create a snapshot because you cannot create a standalone snapshot. It needs to belong to such a result. Now, we are going to create a result and we're going to add the snapshot to that result, but we're not going to do it in this function. We're going to do it in the view, which means that we need to pass this result to this function. So I hope this is not too confusing, but basically in our view that we're going to adjust here in a second, we are going to create an LLM result object and we're going to pass the ID of this object here to this tool as a parameter. So also the LLM can manually set the proper ID here. So I'm going to say here LLM result ID, which is going to be an integer, is going to be the first parameter of this tool, but also of the other one. There you go. And then the rest is quite trivial because all we have to do now is we have to create a snapshot object. Snapshot is going to be equal to snapshot. Of course, we need to import this. So we're going to say at the very top from models import snapshot. And then here we're going to say that the snapshot ID is obviously the snapshot ID. Ready is going to be equal to false by default. Then the LLM result ID will be the LLM result ID. And the data will be empty in the beginning. That's that. Then we're going to just say snapshot.save to create the database object. And for the LLM, we don't need to return any special information. We're just going to say successfully created snapshot. So we're going to copy this and we're going to do the same thing down here for the Glassdoor function. After we get the snapshot ID, we're going to do the exact same thing. And we're going to get rid of the rest here. Also, it makes sense to adjust now the descriptions. So for the LinkedIn tool, I changed this now to search for jobs on LinkedIn by multiple parameters, return snapshot ID, use the LLM result ID to attach the snapshot to the LLM result object. For country, always use proper country codes and some examples. Nothing too fancy. You can adjust this again the way you want. And for Glassdoor now, I'm going to do the same thing. Just I'm going to replace LinkedIn by Glassdoor. Then I also want to have two helper functions for the functionality that we commented out here. I want to have one function for checking if a snapshot is ready or not, and another one for getting the snapshot data. These are not going to be agent tools. These are just functions, so I don't have to constantly write the same code. So I'm going to take this, I'm going to delete that, and I'm going to also do the same thing here, but this time I'm going to cut it. And at the bottom, I'm going to define a function. Let's call it isReady. I'm going to pass a snapshot ID, which is going to be a string, and that's going to return a Boolean. And then here we're going to say URL is that. This is now for the checking if it's ready or not. And we don't actually want to have a loop here. We just want to get the requests and we want to return whether that's the case. So actually, we just want to check, is it ready or not? And we're going to return this exact expression. So I'm going to return that. And of course, I'm missing the headers, so we need to actually get this and paste it here as well, like this. And for the other function, we're going to say this is going to be the getData function for a snapshot ID. So snapshot ID is going to be passed, and we want to get the data. This data is going to be a dictionary. And here we have this URL. We still need the headers here, and the rest is already correct. So here we just get the JSON object of the snapshot data. Cool, so now let us move on with the view or to the view. We're going to replace all of this now by new logic because we're going to have to create an LLM result now, and we are going to have to store everything properly, and then we're going to also have to call a task. But before that, we have to set up Celery, so this is going to be the final step to make this really professional. For now, let's just handle the database storing of a new request, of a new prompt. So we're going to start with an empty context object, which we're going to fill up with different things depending on the branch that we get into. I'm going to start by saying if requests.method is equal to post, then I want to do something, and otherwise I want to do something else. Now, what do I want to do when I post? I want to get the data, I want to get the prompt, I want to create an LLM result object, and I want to store everything there. So getting the prompt is actually the same as before. We say request.post.get and prompt. Then we say if there is a prompt, we can try to create an LLM result object. So I'm going to say LLM result is going to be equal to LLM result. That of course needs to be imported. So from .models import LLM result. And we're going to have to set a couple of things by default. The most important one already here is the prompt. So the prompt is going to be the prompt. The title is just going to be a generic title. It can be reset by the model. We need to implement this functionality. So I'm going to provide my model or my agent with another tool, which is set the title of a specific LLM result. So by default, it's going to be just new job search, but we're going to be able to adjust this. Status is going to be pending. That is, I think, the default anyway. And then the owner is going to be whoever sent this request. So request.user. Now, of course, to have this request user, we need to actually require login. So we need to make sure that this is actually only accessible to someone who's already authenticated and logged in. And for this, we need to import from Django, contrib, auth, decorators, the login required decorator. So just login required, and this means we cannot access this view unless we're logged in. And if we're logged in, we have a user object which we can assign this result to. Finally, just save this. So LLM result save. And then we need to take the ID from this result and pass it to the agent, to the invoking of the agent. Which reminds me that we don't have yet a way to pass this information to the agent because our function search jobs with agent doesn't take this information in. It is required for calling these two functions, but the agent doesn't have the information. So actually here we're going to say LLM result ID, which is going to be an integer, is passed here to this function. And now, of course, the professional way would be to use context. We could create a context object, pass it and everything. We're going to do it really, really simple here. I'm just going to do an an enhanced user prompt where I'm just going to include some information. Not the most professional way. Don't do it for an actual SaaS project, but it's just a quick fix that we can do now. I can say user request. And before that, I can say a couple of things. I can say the ID of the LM result is, and then I can say LM result ID. So we know what we're dealing with. This can be passed to functions. And I can say always use this ID when calling tools. Also, when we're already in this file again, let's briefly create another tool for setting the title. We're going to say here def set results title. That is going to take in an LM result ID, integer, and a title string. I'm going to also return a string. And this is going to be a tool. I'm going to say set results title. And the description is going to be this here. Set the title of the LM result object in a database for asynchronous processing. Choose a fitting title. Quite simple. And what we're going to do here is we're going to get the object. So the LM result is going to just be the LM result, which of course we need to import. The class needs to be imported. LM result objects, and then we're going to filter. What are we looking for? The one where the ID is equal to LM result ID. I want to get the first one. Or actually, since we're using just one, we can go with get. Don't need to do filter in first. And then we're going to say LM result.title is whatever we pass as title, and then we're just going to save. Very, very simple. But now we're going to add an additional instruction here, which is going to be not only always use IDs when calling tools, always call the tool or always use the tool for setting the title for the given result ID first. And then always use this ID when calling tools, or always use the result ID when calling tools, or maybe always pass. Always pass is the better way of phrasing this. Okay, so having fixed that, let's go back here to our view. We basically create this object, we save, and now we should call this search jobs with agent function. So we're going to say search jobs with agent. We're going to pass here the LM result.id, which exists once we save it, and then the prompt that the user submitted. By the way, I also forgot here to return success, or any string for that matter. But this function here, this search jobs with agent, doesn't give us the actual result, but we still get something back, which is something like, hey, I submitted this job for processing or something like this. So we are getting some result here, and this result should be part of the context because we want to show it in the browser. So I'm going to say result is equal to result. And now I'm going to do the same thing with prompt. There you go. Then in the except branch, we're just going to say exception as E, whatever it is. And we're going to say context is some error that we could get here. This is mainly for styling and for showing stuff to the user. We're just going to say STRE. And actually, we don't need an else branch. We're just going to do the same thing every time. Return render request. And then let's call this one job search.html. And the context is the context. Or actually, let us just use our existing search HTML and just adjust it. So instead of having an input, I would like to have a text area now. So we're going to say text area is going to be a text area. The name of this text area will be equal to prompt. Rows is going to be 4. Columns is going to be equal to 50. And placeholder is your prompt or something like this. Now to keep the prompt in the text area, we're going to also fill it here with prompt. And besides that, we're going to add now result and errors. I'm going to copy paste this because this is nothing new or fancy. We're just saying if there is an error, show an error. Otherwise, don't show an error. And if there is a result, show the result. Okay, so at this point, we need to start thinking about Docker, Celery, and the whole asynchronous processing. Why? Because now we can create these entries, these snapshots in the database, these results, but now we need to actually go check if they're ready and process them asynchronously in our application. For this, we need a Celery worker. I do have a video on this channel where I go into Celery and explain how to use it, what it is. Basically, if you don't want to watch this video, if you don't want to go deep on it, Celery is a task queue, a distributed task queue, where we can just schedule stuff to be executed when possible, and we don't have to wait for it. So it can give us the results. We can get the results back once they're done and we need them. So I want to start now by transitioning the entire setup to Docker, or to be precise, Docker Compose. So we're going to run Celery, Redis, and our Django application in Docker Compose, or with Docker Compose. Now, if you don't have Docker on your system, you can go to the documentation at docker.com. And there you can find the installation instructions here for Mac, Windows, and Linux. I think you don't find any instructions here for Arch Linux, but there is just a pacman package as far as I know, where actually it says here experimental package. I mean, I'm using Arch and it works perfectly fine. So that's not a problem. Just install Docker on your system. Also make sure you have Docker Compose so that you can use the command line tool. And then we're going to start by creating a simple Docker file in our application. So in job SaaS, we're going to right click and we're going to say new file, Docker file with a capital D. Here we're going to start with a base image. I'm going to say from Python 3.11 slim. Then I want to define work directory to be /app. I then want to copy the PyProject toml and the UV log file because that's what we need to install the packages. So I'm going to say here copy PyProject toml uv.log /. Then what we're going to do is we're going to run the command pip install uv because uv doesn't exist necessarily in this Docker container by default. And then I'm going to do uv sync -- frozen to actually apply the packages, or to actually get the packages as defined in the uv log file. Then I'm going to say copy everything, and then I'm going to say expose port 8000. Next, we also want to create a Docker Compose file here in the same directory, so docker-compose.yaml. And this file will define our services. As I mentioned, this is going to be our Django application, so basically backend and frontend in one. We're going to have the Celery worker, and we're going to have Redis as a queue, as a message queue or message broker, so to say, for Celery. So the services are going to be defined like this. Web, we're going to say that the build is going to be the current directory. The environment file is going to be .env, like this. Then we're going to also map the current directory. So volumes is going to be /map to /app. Then the ports mapping is going to be 8000, 8000, restart always. And now important, since our Celery worker will also be part of our application here, we need to make sure that we use different commands because we're going to use the same Docker file essentially for Celery worker and for web. So For this reason, we need to say command here is going to be uv run python manage.py run server 00008000. Now, of course, in a professional setting, you would use Gunnycorn or something like that. I'm just going to keep now using the development server here for the sake of simplicity. The next service is going to be Redis. And Redis is super simple. All we have to do is define that it exists, and then it's going to be used by Celery, and that's basically it. So image is going to be Redis latest. And then we also do restart always, and that's basically it. That's Redis. And then finally, the Celery worker will also build in the current directory. We're going to also use the same mapping and the .env file. We're also going to say restart always. Now, this is going to depend, however, on Redis. So we're going to say depends on, and then we're going to say Redis. So it cannot run without Redis running successfully. And then the command is going to be a different one. Now, this might be confusing if you don't know Celery, but it's going to be, first of all, again, uv run Celery-a core, which is our directory here. And then it's going to be the worker with a log level being equal to info and a concurrency equal to 2. So we don't have that yet. We're going to assume that it already works, but this is the config, and then we need to implement now the functionality in our application. Okay, so let's go a bit quicker now. We're going to go to core, we're going to go to settings, and at the bottom, or wherever you want actually, we're going to put some Celery settings. This I'm going to copy paste. Now, if you have a problem with this copy pasting, you will find all of the code on my GitHub, and you will find a link to my GitHub in the description down below. But basically, these are just some settings like what is the backend for Celery, what is the broker URL that we're using. In both cases here, we're using Redis. In a professional setting, I would probably be using RabbitMQ as a broker, and Redis is the results backend. But for now, we're just using Redis here. And yeah, these are just time zone and what kind of content is accepted and so on. Nothing too fancy, just basic Celery settings. Then what we also want to do is we want to create in core, in the main module here, we want to create a celery.py. And one thing that we need to do in our UV setup is we need to install Celery and Redis. So we say UV add Celery and Redis as packages here. And then I'm going to copy paste this code here as well. Again, you will find it on GitHub. Basically just getting the Django settings module so we know where it is. We're creating a Celery app. We're auto discovering tasks. So this is so that we can automatically find shared tasks that we're going to define here in a second. And yeah, that's basically it. A basic Celery setup. And the last thing that we need to do is we need to go to this init.py file, and we need to just make sure that the Celery app is here part of this double under variable all, so that it is automatically exported and executed. Okay, so that is the setup, but now we need to actually use Celery to process tasks. So in our job application here again, we're gonna go and say new file, and we're gonna create a file called tasks.py. And in this tasks.py, we're going to define a shared task. This is a decorator from Celery, which basically means that we can execute this asynchronously. And the goal of our task is to get for a specific LLM result object all the snapshots, get the data, and summarize the findings. So it's going to be called something like process, snapshots, and summarize for a given LLM result ID. Now we're going to need a couple of imports here. For example, from Celery, we're going to need the decorator shared task, but also from our own code base, we're going to need from models, the snapshot and the LLM result. And we're also going to need from services, this helper function, get data that we define to download the data for a given snapshot once it's ready. Then we're going to open up a try block, and we're going to say, give me the LLM result with this ID. So the LLM result is going to be LLM result objects get ID is going to be equal to LLM result ID. Then we want to say the status of this now, since we're starting this task here, this shared task, is going to be set to processing. Also, don't forget to annotate this as a shared task. This means that it can be used by Celery even though there are two different running applications here. Then we're going to say LLM result safe. So all we're doing here is we're just updating the status so we know it's no longer pending, it's now processing, and then we'll load all the snapshots. So we say snapshots is going to be equal to snapshot objects filter, where the LLM result ID is going to be equal to the LM result ID. And since our model needs text, we need to craft a data string. So we're going to say data string is going to be starting as an empty string, and then we're going to iterate over the snapshots. So for snapshot in snapshots, set the data field of snapshot. Remember, this is our JSON field that we have here. Set this to be equal to the data that we get from this particular snapshot. So we're going to say snapshot.data is going to be equal to get data for a given snapshot ID, which is snapshot.snapshot ID, which is not the same, by the way, as snapshot.id. That is the database ID, and here we have the actual BrightData ID. Then we say snapshot.safe, and we need to append to the data string now the string version of snapshot.data. Now, if you want to save tokens, if you want to make this more targeted, more focused, more professional, you can also manually choose the fields that you want to include. What I'm doing right now is I'm dumping the whole JSON object that I get from BrightData here into the LLM as a data string. You can filter that. You can radically reduce the amount of tokens if you just get rid of the description of the HTML and all that. I'm just keeping it simple here and adding this data string. And of course, don't forget to add also a line break to have some structure at least. Now, what we want to do with this data string now is we want to extract the information in it. We want to find the actual job listings. And we want to do that in a structured way. So on the one hand, we need to import LangChain stuff here to actually do the inference, to actually get the information, but also we need Pydantic models to force structured output. So what I'm going to do here is I'm going to say from LangChain.chat models import init chat model. This is because now we're going to use a standalone model. We don't need an agent that can use tools. We just want to use a model that gets in some text and produces some structured output. And also I'm going to create a new file here called lmschemas.py. And here I'm now going to say from typing import optional. This is core Python, just type hints. And then also from Pydantic import base model. And now the idea is that I want to define, on the one hand, an individual job listing. So what does one entry look like, which is going to inherit from base model. And then I also want to have job listing or job listings. Let's just use the plural form. And that's just going to be a list of whatever job listing is. So think about it that way. I'm going to define this object. What does a job listing look like? And the thing that we actually want from the chat model is I want to have a list of these things, of these listings. So I'm going to show you how to define that for one field, and then we're just going to copy paste the rest. So title, for example, would be a string. So I say title is a string, and then I can also say I need this from Pydantic first. The field class, I can say this is a field. I use ... and then I can provide a description. This is important because this instructs the model what to do with this field. So it tells it what this field is for. For example, I can say a meaningful title representing this job listing. And then I can do that also with the other fields. So here we have basically the same thing, just with different fields. The only difference that you can see here is we have string 2 times here for the first 2 fields, but then we have optional string. This is because these 2 are mandatory. I always want to have a title. I always want to have a link to the job listing to make sure it exists, and the rest is optional. If I don't have a type, level, summary, or whatever, it's fine. We still specify what it is. They're all just strings, and applicants is integer. But it doesn't really matter if they're always there, always provided. But this is the model that we want to force. We want to have a list of this here. So we can save that. Also, let me save these files in case I didn't save them. And now we go back to task and we create an instance of our model. So I'm going to say here, chat is going to be init chat model. I'm going to say that the model is GPT-4. Actually, we can go with 4o mini because we don't need tool use. So I can use a cheaper model. So GPT-4o mini, and then I can say that I want to have a model with structured output. So I can take this model and turn it into a model that uses structured output. So I can basically say structured chat is equal to chat. And then the function is with structured output, and we provide a Pydantic model here, which is in our case something we need to import from LM schemas import job listings. So I can say job listings. And then we can just say result is equal to structured chat.invoke on a message history. And this time I'm going to use the message classes. So from, what was it, LangChain, messages, import human message and system message. And then we're basically going to copy paste this here. System message, human message. You are a helpful assistant that summarizes job search results. Make sure to always include links and then summarize the following job search results. And we get the data string that we got from BrightData. So this part here is blocking the worker. This is not done asynchronously. Here we're actually waiting for the response, which also means that I'm going to get the result here and I can proceed to do something with this result. And the only thing I actually want to do here is for every job listing I get, I want to create an equivalent object in the database. Because if you look at LLM schemas and then you look at models, you're going to see that this is basically the same structure, the same model. So I'm going to go now to tasks and I'm going to say for job listing in result.listings, or actually, what did I call the field? I'm super smart. Of course, I didn't give it a name. This has to have a name. So it has to be listings, list job listing. So this field is called listings. It's a list of job listings. And now I can access it here by saying result.listings. And for each result, I want to create a database object. I'm going to say job listing result is going to be equal to, and now of course this also needs to be imported, job listing result. Then LM result is going to be equal to LM result, which we still have from before. And the rest is just going to be the fields from the listing applied to the database model. So just title is job listing title, job type is job listing job type, and so on. So this is the result, and then we can just go and save it, job listing result.save. And once all of these are processed, we can say LM result status is equal to ready. Now we're done, and then LM result.save. Then we're also going to say successfully processed and summarized LM result for, then maybe use an F string here, LM result ID. And if there's a problem, except exception as E, print STRE, and re-raise it. Yeah, just to keep it simple here. But that is the main idea. We have this task and this is going to be queued with Celery. So we're going to instruct now in a view that this should be delayed. Now, when this happens is a different thing. So we're going to go the simple route here because the video is already quite long and I don't want to make it more and more complicated. But essentially what you could be doing, what could be a good practice here is you could have some schedule, some Celery beat schedule, where every 5 minutes, every 2 minutes, every minute, whatever, you're checking if there are any results that have all their snapshots ready, and then you just load them. This would be the professional way to do that if you want to have a quick response time. An alternative would be, and this is what we're going to do here now for the sake of simplicity, when the user checks, we're going to see if they're ready and then we're going to download. So for this, we're going to go to views and we're going to create another view, which is going to be results list view, which is going to take in a request, of course. And we're also going to annotate it with login required. And what we want to do in this view is actually quite simple. We want to iterate over all the results that are pending, so that are not processing or ready. We want to see if all their snapshots are ready. And if yes, we want to schedule the task. We want to enqueue the task. So I'm going to say here for LM result, in LM result objects filter, the filter is going to be the status has to be pending. What we're going to do is we're going to get all the snapshots. So snapshots, now I think I don't have the class here, so let's import it. Snapshots is snapshot.objects.filter. And what do we filter for? We want to have snapshots that belong to this LLM result. So we're going to say LM result ID is going to be equal to lmresult.id. Also, one thing that we should not forget is to filter for owner. So the owner of the result has to be the user that is sending this. So has to be request.user and status has to be pending. So now we're getting all the results for this user that are pending. We're checking, or we're getting all the snapshots for these individual results. And then what we do is we check if they are ready. So for snapshot in snapshots, if not snapshot.ready, because some of them could be already ready without us checking. So if this snapshot right now is not ready, but it could be ready, or it actually is ready when we check BrightData. So we actually need to do the check. We need to go up here and say, what was it? Is ready. So if it's not ready, the status is not ready, but it is actually ready. If that is the case, for this snapshot ID, then we're going to say snapshot.ready is true, snapshot.save. So we're just updating the status here. And then we're just going to say if snapshot or snapshots.exists, and if all of them are ready, all s.ready for s in snapshots, then we can enqueue our task. So I'm going to say from tasks, import, process snapshots, and summarize. And down here, I'm just going to say process snapshots and summarize. The function is called delay. So now we're delaying with a specific ID, which is going to be the LM result and the ID of that. So that is what happens every time when we go to this view. But the main functionality of this view is not just updating everything, but actually showing all the results. So we're going to say results is equal to LM result objects again, filtered. This time we want to have all of them, not just the ones that are pending, not just the ones that are ready. We want to have all of them that are owned by the user that is sending the request. We also want to order by ID. And then we want to create a list called results data, which is going to contain a bunch of information that is relevant for showing stuff in the HTML, like how many snapshots do we have, how many are already processed, so we can see the status there. And for this, I'm going to say for result in results, I'm going to say total snapshots is going to be equal snapshot dot objects filter that belong to this particular result. So LM result ID is going to be LM result dot ID. And from that, I want to have the count. So how many are these total? And the ready ones are going to be just ready snapshots filter. And I'm going to say that, but I also want to say status is equal to ready, or actually it was ready true, right? Ready is equal to true. So then what we're going to append is the following results data dot append. We're going to append a dictionary here, and the dictionary will contain, on the one hand, the result object itself. So result is going to be, or actually, sorry, in quotation marks, result is going to be result. Then we also want to have the job listings. That is going to be a list of result.job listing results, because that is the related name that we defined in the model. Because result is our LM result, and this is the back reference, so to say, to the job listing results. I'm going to get all of these. And then we also want to have this total and ready snapshots like this. And finally, we're going to just say at the end of all this, return render request, and then here we're going to say job slash results list.html, not context but results data, and of course this has to be in a dictionary, results pointing to results data. Okay, so this is quite a lot. Let us just briefly recap to understand what we're doing here again. We have a Docker Compose setup. Here we have 3 services. One is the Celery distributed task queue. One is Redis, which is the broker and backend to Celery. If you don't want to understand this in more detail, it's just a task queue. We just submit stuff there to be executed asynchronously, and we get the results when they're ready. That's basically it. Then we also have our backend and frontend, so our Django web application. These are the 3 services in Docker Compose. Now we also have authentication, which I'm not gonna go into again because that's quite simple. The interesting stuff happens in the views. We have one view for handling the prompt, so handling the post request with the prompt. Once a user submits a post request, what we do is we create an LLM result object in a database with a default title, with the status pending belonging to that user. Then we instruct a LangChain agent to use tools that access BrightData to get data at scale from LinkedIn and from Glassdoor. And what these tools do is actually they just submit a request to BrightData. BrightData is going to give us the answer, but not right away. We create a snapshot and we're getting a snapshot ID. We can only receive the data when the snapshot is ready. But in order to not wait, what we do is we just store the snapshot in a database and retrieve it later when we need it. This is what happens in the other view. Here, whenever we list the results, we check if there are any snapshots that are ready, and if all snapshots belonging to a specific result are ready, we start actually getting the data. This is what we do in the Celery task asynchronously. We get the result, we change the status to processing, we then get all the snapshots that belong to this result. All of them should be ready. We get the data for all of these, and we instruct another large language model, not our agent, to summarize these results with structured output defined in LLM schemas, so that we can then get the final object. We then translate this to the job listing result, database objects, save everything, and we're done. Now, this video is already getting quite complex, so I want to speed things up a little bit. What I want to do now is all the design stuff that is missing, and I'm sure we have some mistakes here and there. I think we definitely, or I definitely messed up some symbols or some parameters or something, so we're going to fix that too. But what we're going to do now is we're going to style the application, and we're going to write the HTML code, which is just going to display all the results because the functionality is already here. We're going to do all of this in Cursor. So we're going to use Cursor to speed up the development of the user interface. I don't want to teach you how to design applications with CSS and HTML and everything. I just want to show you how to do the functionality. We already did that. We're still going to do some bug fixing, I guess. But now I just want to instruct Cursor with all of this context to generate the HTML file for listing the results with a collapsible section. And then what I want to do is I also want to style the application to make it look more professional. So I'm going to go here. I'm going to say, look at tasks. I'm going to add this to a new Cursor chat. I'm going to do the same thing with models. I'm going to do the same thing with LLM schemas, services, views, and also, I'm not sure URLs. Actually, we do need to also add this to a URL. Maybe we can also instruct Cursor to do that. So that shouldn't be too difficult. And now let me show you how we're going to do that. We're going to say, look at the views I have and the HTML documents they refer to. If these don't exist, create them. If they do exist, adjust them so they work. Style them well, but keep the code minimal. Don't do anything I did not ask for, and try to do what I asked with as little code as possible. So my goal with this is to get an HTML file and some styling that works, but I don't want to have anything that looks super huge. I want to have code that when you look at it, you say, okay, I immediately understand what's happening here. I don't really care. And I'm just gonna, generate this because I'm not gonna type it myself. Okay, so it seems to have done what I wanted. We have a bunch of CSS that is irrelevant, so we're not gonna talk about this. This is just styling, styling, styling. What is actually interesting here? What is actually technically relevant for us as backend engineers, let's say? So what is really interesting is that we're iterating over the results. So we pass results as context, remember, in the view. Then we go for entry in results, and then we just go to the snapshots, to the ready snapshots, total snapshots to display the numbers. And then we just say job listings. For each listing, we get the individual attributes and we display them in different ways. This is why I want to copy paste and generate this, because the only relevant thing here, knowledge-wise and practice-wise, is that you have the objects and that you're accessing the attributes. How exactly you're doing this, how exactly we want to visualize and show this is up to you. I hope this looks decent, but I guess it will look okay. And then we also have the search now, which is basically all still with a bunch of CSS, and the rest is unchanged, I think, for the most part. Yeah, I mean, it has some examples here, but the functionality is basically the same. So we can accept that, and let's see if this works first try. For this, let me go back to VS Code, and here now, let's see what would we have to do for this to work. On the one hand, we want to do Docker compose build. Maybe this already fails. Let's see. Yeah, it fails because it says that services vep volumes must be an array. So let's go to that. And of course, because I forgot this hyphen here and the hyphen here, makes sense. What else do we have? UV lock is not found because UV is not part of job SaaS, but UV lock is part of the outside package. Now, I think we could do a quick fix maybe if I just put it in there. Let me just copy it and see if that works. So let's go and do that. Docker compose build. PyProject Toml, same thing, of course. Docker compose build. Okay, so the building worked. Let's now try to do Docker compose up. I think if we have syntax errors, it should already fail. So it looks okay, I guess. Now, what we definitely need to do is we need to do the database migration. So I'm going to open up another terminal here, and I'm going to say in job SaaS, I'm going to say Docker compose exec web bash. And here I need to say Python manage py make migrations for all the tables. And of course, we need to do this with UV. Don't forget that. UV manage py make migrations, UV manage py migrate. That seems to work. So we can see the login page works. Now, one thing I noticed is that in Cursor, I did not provide the instructions to also style the login and the sign up. So let's change that quickly. So I said, awesome. Now please also style the login, sign up, and also add a home page where we can go to results and search. Okay, so he seems to be done. Sign up, again, a bunch of CSS. Nothing really changed too much. I mean, we have here form errors. Okay, that's just displaying errors in the form, in the validation. Besides that, we just have fields in the form. So we're not just rendering the form as P. That's fine. We're just showing the help text in the form itself. This is not really important for our application. Login, we have the same idea, a lot of CSS. And same idea with the form here, same idea with this. And also it changed something here about URLs PY, which is relevant. This is now actually something I forgot. I did not have results as a view, and I now also have home as a view. So these two are important. We didn't have them before. Make sure you include these. I'm going to accept this, and let's see if this already is enough. There you go. We have a login page. We can also create an account here. I'm going to go back to login. I think we should still have the admin with admin 123 admin. Now we still don't have a profile page, so maybe I should add a login redirect, but let's ignore this for now. And here now we have our homepage. So here we can say, find and track the roles you care about. Nice. I can do start a search, review results. I don't have any results, but I also don't get any error messages, which is good. So let's see if that works actually, first try. And then I can say start a search, and I can say ML engineer, what did I say? ML engineer in Lyon from LinkedIn. Let's just do a single one to see if that works. Let's see what happens. Okay, it's loading, so it's submitting this. Now it gets here, I have searched for ML engineer job listings in Lyon LinkedIn. And yeah, the message is not really important. What should be interesting is I can go here to review results, and I see new job search pending, snapshots ready 0 from out of 1. If I reload, I see the same. If I reload again, now I get a problem because it doesn't know what LM results are. Where is this? This is actually in snapshot objects filter, total snapshots. Now, meanwhile, while I'm troubleshooting, you can see that Celery completed the task. So this is now actually successfully processed and summarized, but I still need to fix the problem. So what is that? This was actually a view, not a task. So here, yeah, of course, it's not LM result ID, it's result ID, because I'm iterating over results, and this is the variable, not LM results. So hopefully that works. And there you go. New job search, machine learning engineer, mid-senior level, full-time, batch is cooking for a machine learning engineer to enhance, is looking for a machine learning engineer, sorry, to enhance their AI strategy. Then ML engineer, data scientist, and if I click on the jobs, I should also be taken to this page. There you go. And yeah, let's try now to combine the two sources. Let's go start a search and say ML engineer in Vienna without specifying a platform. In this case, I assume it would look for both. It would look for LinkedIn and Glassdoor. Now it submitted the job successfully. So let's go back. Let's review results. And now we have here new job search. Search is still processed. Okay, now we still get only one. So probably it decided to only go for LinkedIn. Maybe I have to provide specific instructions that I want to have both, but it's processing. So it's being summarized. And there you go. We have the new job offers here. Let's try to see if I can do an instruction like ML engineer in Vienna from LinkedIn and Glassdoor. Okay, now we have two snapshots, so now we have to wait for both to finish. Then they're going to be combined. Let's see if there are any problems with that. So now you can see both of them are ready, which means that now since I reloaded, it's no longer going to be pending but processing. And now I have to wait for both of these to be retrieved to get the data, to do the summary, and then I'm going to get these job offers here as well, or not job offers, but job listings. There you go. And we have all the jobs here as well. Now, I'm not sure if all of these are from LinkedIn or if anything from Glassdoor is included, because I'm not sure that we have actually Glassdoor in Austria, but you get the idea. So this is a SaaS application or a prototype for a SaaS application that can scale, and it can scale because of two reasons. One is because we're using Celery, because we're actually processing tasks asynchronously. We're not blocking the workers. And the second reason is because we're using BrightData that allows us to access all this data at scale. Of course, this works with one user, but it also works with many, many more users because you're just pinging their API. They're also processing it asynchronously on their end. And this makes the entire application scalable. So as I said, you will find the code for all of this in the description down below. You're also going to find a link to BrightData in the description down below, the sponsor of this video. And of course, you can now extend this, more functionality. You can do the Celery beat schedule to not have to reload this page to load new entries when they're ready. You can also use much better styling, as you saw with cursor. You just have to provide the proper prompt. I'm actually quite surprised that this worked first try. So yeah, seems like I did an okay job coding this year while recording for a pretty long time now. I hope this was educational to you guys, and that's it for today. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Don't forget to check out BrightData, the sponsor of this video. You will find a link to them in the description down below. And besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.